n log n?
Any approach is fine.
Because if it's a sequence of numbers, then it can be made in theta n.
Theta n. Okay, don't worry. Try.
Can I? Is it my turn?
Yeah, sure, no problem.
Oh, okay. So since the algorithm takes a sequence, so it means it's already sorted. There are two n numbers,
so
which means
numbers are not sorted.
oh, numbers are not sorted.
Yeah, numbers are not just sequence.
Can I try, Professor?
Yeah.
So I think this is similar to merge sort, but instead of sorting them, you just stop until you have two pairs, and then you're gonna check both of them, and then you're gonna switch the places. For example, we start with 1, 3, and then with merge sort, but we're not sorting it, so we get that kind of pairs 1, 3, and 5, 9. But after that, we switch 5 and 3, so we get 1, 5, and 3, 9, something like that. So it's n log n.
Can you explain one more time, then everybody can understand?
It's sort of like merge sort, because in merge sort you are dividing the big list into smaller lists until it is pairs of 2, right? And then after that, you have the pairs, you calculate them, and if there is other numbers, other pairs, then you're gonna switch the numbers. For example, 1 and 9 and 5 and 3, and then you merge them again, and then you merge sort them again.
Okay, good try. Great. So anyone else?
This is Min-Heng. Can I go?
Sure.
What I would do is just sort the whole array and then pair them from the very first and the last one, and go on to the middle, and that way the O will be just n from sorting and log n by binary search.
So let's say what the Min-Heng says. So sort sequence. How long does it take? So known sequence is n log n, right? So any quick sort, any merge sort, that is n log n. Okay, sort them once. Then, since the array is sorted, I'm going to pick the first one and the last one. First one, then keep the minimum, maximum, minimum, maximum, minimum, maximum, minimum, maximum, minimum, maximum. That guarantees you'll always find the even distribution of the output. Okay, everybody understand?
Yeah. So at the end, it just takes n log n.
Yeah. So great job, Min-Heng. Anyone else has different idea? Any crazy idea? No? Okay, thank you, Min-Heng. Okay, Min-Heng is right, Min-Heng is right. Min-Heng.
It's Min-Heng.
Min-Heng, okay, thank you. So what we just experienced is the power of the sorting. Once the data is sorted, then we can do any additional task much easier. Everybody agree? Right? So in computer science, the computer scientists spend about historically 25% on the sorting. Okay, when the era of the mainframe. So the sorting is the best studied problem in the computer science with many different algorithms known. And most of the interesting idea we will encounter in the course and can be taught in the context of sorter, such as divide and conquer. We sometimes call divide and the rule, and randomized algorithm and low bound analysis. And we should have all seen this algorithm, so we'll have a concentrate on the analysis. So efficiency of the sorting. So sorting is important because that once a set of the item is sorted, the many other operations become very easy. So for the n log n is a sub-quadratic algorithm, meaning So we know the quadratic algorithm. So n log n is much efficient than a quadratic. So when numbers are increasing, n log n is still handy. When it is n squared, it's too difficult to handle. Your computer is too busy to solve that issue. So when we talk about n log n, if you remember the previous slide, the n log n factorial all the way there. So n log n is acceptable, and your algorithm needs to be tightly stay in the boundary of n log n. So application of the sorting is most common one is a searching. So binary search tree, we understand what is the binary search tree, right? We do keep halving it. There is less items, okay? So what's the issue with the binary search tree? Binary search tree, not the BTS. What's the issue? Why is the BST is difficult to maintain?
It needs to be balanced.
Okay, perfect. So binary search tree always need to be balanced. And when we talk about balanced binary search tree or perfectly balanced binary search tree, we have to keep maintain. Whenever we insert it or whenever we delete it, we have to maintain the tree structure itself, tighten up. Then this time takes a while, okay? But it's much better than a random numbers, okay? So heap and prior queue is in between. It is easier to maintain than a binary search tree. It is much better than a randomized value, okay? That is a heap, and we're gonna talk about priority queue, okay? So let's do as a application of sorting and find the closest pair. So let's think about for 1 minute. So given n numbers, find the pair which are the closest to each other. How can you find?
What do you mean by saying find a pair that are close to each other?
So closest pair. So given n numbers, one. So find the pair which are closest to each other. Let's say it should be 8 and 7, 6 and 5, and 2 and 4. Okay, closest to each other. Do you understand? Okay, so how can you find this? Quickly.
You can just sort and just take the first two and the second two and so on, no?
Okay,
Yeah.
great. Thank you, Roshan.
So that's ON, because
Yeah.
that's the linear scan.
Okay, Youngjae, thank you. Youngjae, you were just repeating the what was it, Roshan's mark, right? Can you repeat again?
So if you sort, and then the closest pair will be next to each other. So you have to, that's just a linear search.
Okay.
I mean, linear scan.
Okay.
So that's ON.
Okay. Same comment to the Roshan. Okay. So okay.
Yeah.
Great. So once the numbers are sorted, the closest pair will be next to each other. Then it will be linear scanning to complete your task. Clear? Okay. So next question. So application of sorting element uniqueness. Given an n item, they're all unique, or are they any duplicates? How can you find this quickly? So let's give more chances to who the score is lower. So I'm gonna pick the Yejin and Subin and Hanmin, Lim Hanmin, and Lee Seongjun.
Professor,
Yep.
can I ask you a question for the previous question?
Okay.
What if the numbers are 1, 2, 3, 34, 35, 37?
1, 2,
3, 34, 35, 37, something like that.
Okay. Then you are sorting 3, 34, 35, 37. Closest pair. This one and this one, this one.
But isn't like 34 and 35 the closest pair? No?
Right. Okay, so let's solve this problem one more time. So, good point.
But this is still better than the other option.
Okay, I understand that. Okay, slide. Good point. Who was that?
It was me, Woo-hyun Park.
Park Woo-hyun. Thank you. Perfect comment. So what do I do is I'm going to sort them once. Okay. Then if I do a linear scan, left or right, I'm going to find that, okay, who's my closest? In the view of 2, 1, 3 is the same. In the view of 3, 34 and 2, oh, okay, I should hook up with the 2. In the view of 34, 35 and 3, oh, I should hook up with the 35. In the view of 35, 34 and 37, I should hook up with the 34. In the view of 37, I should hook up with the 37. Okay, I don't need to find all pairs, but I need to find the closest pair, which means I can do this in a linear scan, left and right, left and right. Clear? Okay, thank you, Woo-hyun. Can I move on to next? Okay. So application of the element uniqueness. How can you find the unique number, or if there is a duplicate, how can you find it quickly? Okay, so now I'm gonna pick the Yu Jungmin, and I'm gonna pick the Shin Yejin. So whenever you're ready, let's give everybody's equal chances.
May I go first? This is Yejin.
Okay, sure.
I think we can pick an element and do the search to the whole array. And then if one of the element is equal to the key, then we can just return there is duplicate.
What's the analysis of? What's the low bound?
We can use for loop.
Yeah,
to
that is, yeah, 2 for n square.
Yeah.
Yeah.
I think the n square is too high for
Yeah,
it.
so, okay, good. Yejin, good try. So anyone can do a faster than this?
Yeah, I can do it in n log n.
Okay, Janar?
So first, we have to initialize the tree. I mean, it doesn't really matter which tree. They're, I mean, all the same. So to initialize all the numbers, it's gonna take n, and then for each number, for each other number that we're gonna search inside a tree, the searching time will take log n, because it's a binary tree. So at the end, it should take n log n big O.
I think I can make an n.
So I have another.
Okay, go ahead. Who's
So-
this?
This is Jungmin Yu.
Okay, great. Thank you. Thank you for
So-
participation. Yeah.
Initialize initialize variable min. So check all the items in the set from the first one, and then like compare with min, and then when it is the minimum value, change the min to the new item. I mean, can you understand? Like,
Okay, so,
so
the job of this question is, can you find the duplicates quickly
Yeah,
as
yeah, yeah,
possible?
and-
Okay,
yeah.
go ahead.
Can
don't
I
worry.
try?
Okay. So let's give a Jungmin chance again, continuously. I can see that Woo-hyun can solve it. Jungmin, can you raise your voice again if you want to?
I think I need more time.
Okay. All right. So Woo-hyun?
I think you just have to sort it and then compare the first and the second and third and so on.
That takes n log n,
Ah,
right? Can you make n? I think I can make n time.
Professor, can I give it a try?
Sure.
Oh, I would use hash table to
Oh, yes. Yes.
list all n numbers and find duplicates on the
Yes.
like nodes.
Okay, perfect. So everybody understand? The key is hash table. Let's say I have an n size of hash table, and the new numbers are coming in a sequence. I'll put it there. Okay. If there is a duplicate events happen, how quickly can I find it? I can find it n time because I'm just reading all the values and that's it. My hash key will solve it. Is it overflowed or not? Then I can quickly find, oh, there is overflow. What's the analysis of it? N time. Clear?
Yep.
Yep. Okay, thank you. Okay, so for those who does not understand properly, so I'm gonna explain one more time. So my job is find the all unique or any duplicates. Let's say there is a random numbers that are coming in. I want to know, is there a duplicate or is that all unique? Then what I have to do, I have to have hash table first. Then I'm going to keep reading the value. That's for I to n, read the value. Then hash it and put it to hash function. Then it will keep fit it in, right? Then after ending it, there is no event of duplicate, meaning all numbers are unique. If not, if there is some event, oh, there is a value already, meaning there is a duplicate. What's the analysis of it? What's the upper bound, the big O notation of it? I can do it just by reading once. Clear? Okay, thank you. So the mode, so what's the mode? So given a set of n items, which elements occur the largest number of times? So how can you find this? So do you understand the problem? So mode is, so given n items, I have random items, and which all elements occurs the largest number of items. How can you find this?
It's gonna take n.
Okay, I think I read your mind. Anyone else?
I can do it and
Okay, let's give a Yuha chance.
I think I'm gonna use the dictionary.
Dictionary? Okay.
Yes, and then just put all the numbers. So I think that'll take like ON. And then like after that, I'm just gonna go from the start from the dictionary until the end, and then just find the largest max.
Okay, so good try.
Value.
Okay, dictionary is implementation of your insertion and deletion with the data structures. Okay, when you talk, oh, I have a dictionary, meaning the assumption is very high. Okay, thank you. Yuha, you made a great comment. Anyone else?
can I try?
Sure.
I'll use the hash set again. If I'll use the number as a key and the occurrence as a value. If the first keys occurs first time, it will set a value 1 and again increase the value. Then I can count the number of occurrence in n time.
Okay, what's the complexity?
On.
No, you have to maintain your hash key also, right? So previous question, we only need to check duplicate or no. Now I have to care how long is my tail. Which computation is? Right, a little different. I have to maintain this guy. So M is simple because I'm adding this one at the head, or the tail, but we talked about the adding head is more efficient. Oh, then adding head.
I mean, I don't put the actual elements in it, but set a key value as a 1, number 1, and if the key is visited again, just increase the 1 to 2, just plus, then I think it's just ON time.
Okay, so Jongwon says, not just maintain the whole hash table. So create the hash table initially. If there is visit, you are updating this value. When there is a new event, and next time you are input everything 0 to n, then input everybody, the end, then for loop again, 0 to n minus 1, and find the max, right? Find max one, meaning keep the max. Let's say it is max is 0. If value is higher than max, update the max, like something in that way. Okay, great. And we can done in the end time, because end time and end time. Clear? So I'm going to explain one more time what the Jongwon says. So Jongwon says, oh, I think I can solve this in an end time. How? Okay, rather than maintaining a hash table, oh, I can have a hash table with the numbers, which is incremental whenever it's visited. So initially all zeros, and if it is visited again, the +1. If you visit again, is +2, +3, +1, then it's 4. Then make this one take n time, because for I 1 to n, insert to hash table at the end. Then after this event is end, for I to n, max. So max is 0. If i's hash I is bigger than a max, max is hash I. Then the end, return max. Clear? That takes n time. That takes n time. Therefore, n times. Okay? All right, Jongwon, thank you. So we can have a bucket by using a log n. Log n, the bucket mode is, so you make a many bucket already, then whenever the new values are coming in, and you fill it up the bucket. So compute the frequency distribution, so sort them and do a linear scan to measure the lengths of all adjacent runs. The number of intersection k in a sorted array can be found in log n, because a binary tree, using binary search tree to look up the position in here. But this is, we could do this more simple by using hash table. Okay, so one more example. So application sorting, median and selection. So Q1, how can you find the median fast enough? Q2 is how can you find the kth value first? Kth value fast enough. Okay, think about for 1 minute, then I'm gonna pick the lowest scorer, Kang Seung-jae, and the Kim Yura, Ko So-young, and Kwon Hyung-taek, and Lim Han-min, and Park Soo-bin. Okay, so let's give them a chance first.
Professor, I have a question.
Yep.
So question 1 is about
finding the largest item in the set using the median number?
So the find the median of the value Q1 and find the kth value is Q2. Percent.
Okay.
Thank you.
Oh.
Professor, I have a question.
Yeah.
Is the kth value allows duplicates? I mean, like, if there's like 1, 2, 2, is the one the third largest number or second largest number?
The second largest and third largest, it should be n, right? If there's 1, 2, 2, the second largest and the second smallest and third smallest, it should be n, right? Okay, let's start with the Seungjae. Seungjae is not connected. Okay, let's move on to Yura. Yep, I think Seungjae is not in the class, is he? Is he in the class? Okay, so Yura, go ahead.
First, search the set of numbers, yes, and find the length of numbers, and find the number of who has index of length divided 2.
So you sort them once.
Yeah.
Then
find the number.
Sort them once, then you find the length.
Yes.
Then.
And
very close, almost there.
Find the number, the index of length divided 2.
Index out?
The index of.
Oh, so do you mean that you sort them once?
Yes.
You know the length and find in the middle. Is that what you're saying?
Yes. Yes.
Okay, perfect. How about the second one?
Second one, first sort the number.
Sort the number?
Yeah. And find the base number from the.
Okay.
First.
You can also sort them in the reverse way by having a -1, right? Then the kth largest one will be the kth value.
Yeah.
Is that what you're saying, right?
Yeah.
Okay, great. All right. So anyone else want to try? No. So the question is very simple,
Professor?
right? Yep.
Can I try question 1 with the median?
Sure.
It's like it's not really trying to argue what's better, but I thought at first trying to add all the elements and make
add all the elements
and make it an average.
Add all. Okay.
And make an average of it.
Okay. 57. Average of it.
And trying to find
26.5. Okay, then.
Is that right? I think it's about 10.
So the example is 1, 2, 5, 10, 40. Sum that all is 57.
Yes.
Average is divided by 5 is 10.1. Okay.
So we find the value that is most nearest to the average.
Okay. Which is 10.
That was my access to it.
Right. Which is 10. Right?
Yes.
But the 1, 2, 5, 10, 40's median is 5.
Oh.
Professor, can I go?
Yeah, sure. One second. Hyungtaek, thank you. Great job. Great job.
Thank you.
Okay. Go ahead.
First of all, you have to find the length is even number or odd number.
Okay.
And then divide by 2 of the length. So if it is even number, I mean the length is even number, then the index must be the length divided by 2 plus 1. So if to find that index, and it's median. Oh, and then first over the numbers must be sorted.
Okay, so Soyoung's approach is you sort them once, sort everybody, then let's assume it is even. When it is even, then?
The length is even. And I mean, it must find, I have to find it's even or odd.
Okay, let's assume the even first.
Okay, and then divide by 2. Length divided by 2. So if it's even, then the index must be plus 1. Length divided by 2 plus 1.
This one? Is that your approach? So by the definition, median in the even number is plus 2 guys and divide by 2. And by definition, it's the median. When it is odd number, there's one pick median. When it's even number, you pick them 2 and divide by 2. That is the median by definition. Okay, so I got your point, and I think it is very close to the first comment that the other people did, and we know how to solve it, right? So how? So once the sorted, so kth largest will be the kth position. If you reversely sort it, that's the kth, or if you sort it in order, then you can find the k, n minus k is the position that you are looking for, okay? Okay, so do you understand the convex hull? Did you learn the convex hull? No? Nobody learned the convex hull? Okay, convex hull is like a what is this? Stretch rubber band on your finger. Then that the one contour that contains every element. So for example, like this on the figure, let's say I have a random position value and x and y in 2 dimensions. To draw a convex hull of it, I have to find the outer contour. That is my convex hull. Okay, so how can you find the convex hull in a 2 dimension? 2 dimension meaning x and y. So let's think about this for 1 minute. And I'm expecting Subin and Ayong and Hanmin. Who's Stephen Park? Why does he keep asking for a join?
I think it's a guy from business major, no?
Business major. So Stephen Park is either Junghoon, Subin, Woohyun. None of you. Never mind. It's free to take the courses.
That's me actually.
Stephen Park is who?
That's Woohyun.
Okay. All right. Thank you. All right. Okay. So do you understand the problem? So problem is you find the convex hull in a given two dimension. How can you find the convex hull? How can you contour all the values? So convex hull is the a little advanced topic, but that is commonly used and very sophisticated geometry. I think that's 11th grade, 10th grade, 11th grade. You learn the geometry, right? In there, some section in there cover the convex hull. Okay, so we understand the problem. So how can you draw the convex hull quickly? So data is XY position. How can you find the convex hull quickly? Input root length. 3, 4, 5, 2, 7. Expression. Something like this. Ready? So Sunjae is not here today, and Hamin. And
Yes.
I'm gonna ask Subin next. Hamin, go ahead.
I'm not sure. Maybe we have to sort by either X or Y and find the farthest point and connect them.
Farthest one.
Not quite sure about this.
Don't worry. Okay. Thank you. And Ayong and Subin.
Yeah.
Yep, go ahead.
Sort them by X and Y. And then insert the left and rightmost point.
I'm sorry, I think I lost your voice. Can you say that again, please? You sort them.
Sort them by X and Y.
X and Y is not possible to sort at the same time. You have to sort X, then you can sort Y. Okay, then the Go as you want. Sort them in X and Y, then what?
Can you give me more time?
Okay, Subin?
I think I need more time too.
Okay, so anyone else?
It's just a proposition. So we have a bunch of points on a plane.
Yeah.
So first of all, I would divide the entire plane on 4 quadrants, like 4 equal quadrants, and then on each
quadrant. What is 4
quadrants?
Okay.
And then so on each quadrant, I would find a point that is highest leftmost. Like on each quadrant, first I would find a point that is most farthest from the center of the polygon, of the dots. And then I would connect those points on each quadrant. And then my next step would, so there's a possibility that even in that case, there might be some dots that are out of the polygon that I just made. So what I do is that if a point is out of the polygon, then I just keep extending the polygon.
So computation complexity? Very complex.
Yeah.
Okay. So anyone else?
I got my
Sure.
That by looking at that graph for the x-axis, if the value of y, if the value of the if the value of y is the lowest, it may be the farthest from the center, and for y-axis as well, if the x value is the lowest, it will be the farthest from the center. So you can find the coordinates for finding the low.
So I'm sorry, I think I lost the point. So what you're starting is?
So for the x-axis,
okay,
find the value for a value in y the lowest. X value.
So do you mean you sort the x-axis?
Yeah.
Okay.
Then we find the lowest value for the farthest coordinate.
Farthest coordinate. Okay, good try. So find the convex hull is easy in this way. You sort the in x coordinate, okay, then put into the convex into dimension. First, second, you make a draw, okay. When there's third one, you make a draw again, okay. When there's fourth one, meaning I am your upper bound, hey, I make a new line. The fifth one, okay, on the right, okay, and keep continuously. On the sixth one, okay, this line and this line. Meaning, am I higher than previous any of you? If I am the highest, I be the convex hull, convex candidate, okay? This guy. Then since I am the furthest to the right, I should be included, and I'm finding the next one. Then this guy. Oh, I'm the furthest one, I have to include it. Among those, I'm pick the highest and the lowest. Hey, the next guy in the sorted, I'm find the highest y value and lowest high value. Okay, next guy, where I find highest and lowest and continue with them. And find it, okay, highest and lowest. Oh, you know what? I can, in the existing one, that I find the connected one. Okay, do you see how I done? So once you have the x coordinate that is sorted, you can insert to left to right in a hull, and you will find the rightmost point as always boundary. So new point will be boundary, boundary, boundary. So from there, you the candidate you have to compare is eliminated in a small numbers, 2 or 3 at best. Then sorting eliminates the need for check whether points are inside the context hole or no, but you are comparing only 2 usually, but at best is 3. Okay? So this is how we do the convex hole by using a sorting. So what's the problem in the sorting? What is need to be done? Let's say comparison function. So alphabetizing is the sorting of the text string. So library have very complete and complicated rules concerning the relative collating sequence of characters of punctuation. Is a Stony Brook same key as a Stony Brook? Meaning the first capital or the lower. Is this the same key? Or is Brown Bar Williams is before or after a Brown America or Brown, comma, a John? Which one should we go first? How can you do? So we have to have explicit controlling rule for this. So comparison function we apply to each pair of elements, including all the details of it. Therefore, the library can maintain their sorting order, right? So whenever new data comes in, oh, I have to put it. Why do we have to do? Because I want to find the perfect, I want to maintain perfect balanced, perfectly sorted. That's what the library does, okay? So in reality, in computer science, do we need to perfectly maintain the structure every time? Not every time. Because maintaining in perfect order is too difficult and too costly. So we are losing the attention, and losing the attention that we call the heap sort, that is called the priority key. We're going to talk about this. Okay, so programmatic sorting is also equal elements. What's it going to do? If the keys, your hash keys are equal, what's it going to do? Your comparison value is almost equal. Say I only have a letter from A to G, and what's it going to do? With the A alphabet, capital or low letter, then there is a new one that comes in. There's a comma or a bar or something like that. It comes in. What you going to do? Then what we can do is we can have a secondary hash key, secondary keys. Primary key is only the alphabet and etc. From there, first word, the second word, first word and second word. Then we quickly do as a first word, we sort them and put into the same bucket. In that bucket, I'm sort them in the second element. If necessary, I can do the third element. Okay, that is a programmatic in sorting. So how can you handle the equal elements? So binary functions. So any reasonable program language has a built-in sort routine as a library function. So whenever we ask, oh, sort them, we don't do the sort them, bubble sort, or left and right quick sort. We have the best way to do is using the library. Okay, I'm using sort, open the bracket, and close the bracket. So you are almost always better off using the system sort than writing your own routine, because all your sorting algorithm written in the lowest level in the C or assembly. Therefore, it can guarantee the quickest one. So for example, this is a quick sort, the function in C. It all access to the array, and all access to address. And it is fastest implementation of any functions that even you implemented, you cannot beat this. They are already optimized in that field. Okay, so let's say selection sort. Do you understand the selection sort, right? Selection sort is, what is selection sort? In a given set, I'm finding the smallest one, then I can put it in the leftmost. In a given set, I'm finding the smallest one and put it in the left. In the given set, I'm finding the smallest and put it one. So random order from here. First one, from here I found the smallest one. Then I compare them. Hey, from there I find the smallest one and put it. Then your bucket gets smaller, and gets smaller. That's a selection sort. Do you understand the selection sort, right? So selection sort takes task A and task B. Task A is find the smallest number in your item and pull it out of the array and put it the first. Oh, this is what we done. So selection sort takes n times of task 1 and task B's summation. So, okay, go back to the point.
Professor, you muted yourself.
Thank you. So you understand the selection sort, right? Okay. So how can I mute the mic? Okay. Can you hear my voice?
It's now 4:51.
Huh?
The class ended.
Oh, okay. Thank you. So I'm quickly spend 1 more minute.
Yeah.
So I just showed the animation of the selection sort. And selection sort okay. So let's talk about this in next Monday. Okay. And meanwhile, I'm gonna upload your the midterm 1 score. And if you don't satisfy with your score, and I'm going to schedule the makeup exam. So since I made the mistake, which means I opened the too many possible cases, your action was out of my expectation. So some out boundary happened. So the second, the makeup exam will be a perfect score with the 90. Okay. All right. So I will upload as soon as possible, and you can make decision. All right. Okay. Any comment? Thank you. Have a good day.
Thank you, Professor.
Thank you.
Professor, I have a question.
Sure.
If I take second week exam and
The
then
makeup exam, yeah.
yeah,
The higher value will select it.
a higher value. Okay,
Yes.
that was my question. Thank
Okay,
you.
thank you.
교수님, 저 질문이 있는데,
Yep.
제가 이거 클래스룸 구글 다그로 냈는데